Hello everyone, welcome to our presentation. Today we're diving into the language of algebra. We're going to explore how algebraic expressions work and what makes this language so powerful. Over the next few slides, I'll guide you through key concepts and help you understand the basics. I'm excited to get started, so let's jump right in. Let's take a look at slide 2, which is all about evaluating algebraic expressions. Here, we see the different components that make up algebraic language. First, we have the example of operational symbols, which are the signs like plus, minus, multiply, and divide that tell us what operation to perform. Next, we explore the key elements of algebraic expressions, including numerical coefficients, variables, and constants. Understanding these parts helps us interpret and evaluate expressions correctly. We also see that algebraic expressions are sometimes called expressions, and it's important to recognize them as mathematical phrases that combine numbers and variables. There's a section on terminologies, which are essential for understanding algebraic concepts, and this will help us communicate more effectively about math problems. Finally, we have a pair activity where you'll practice evaluating expressions. This interactive part is designed to reinforce what we've learned so far, helping you become more confident in working with algebraic expressions. So, as we go through this slide, keep in mind how these elements fit together to form the language of algebra, which is fundamental to solving problems and understanding more complex math concepts. So, today we're diving into a key area of mathematics, algebra. Algebra is essentially the branch that involves expressions with variables. Now, when I say variables, I mean symbols, like letters, that stand in for numbers we might not know yet. This allows us to create general formulas and equations that can be applied in many different situations. One of the most important concepts in algebra is understanding how to manipulate these expressions, adding, subtracting, multiplying, and dividing variables and constants. This skill helps us solve equations and find the values of unknowns. Algebra is fundamental because it connects to so many other areas of math and real-world applications, like engineering, economics, and even computer science. Its power lies in transforming problems into manageable expressions, making it easier to analyze and solve. So, as we move forward in this presentation, keep in mind that algebra is all about using symbols to represent real-world quantities and relationships, making complex problems simpler and more approachable. Now, let's look at algebraic expressions, or simply called expressions. These are combinations of numbers and variables put together in a way that makes sense mathematically. Think of it as a kind of mathematical phrase that can represent a value or a relationship. The key point here is that expressions can include variables, like the n in our previous example, and these variables are what we call unknowns or placeholders that can change. So, when we combine numbers with variables, we're creating an expression that can be evaluated or simplified depending on the values of those variables. Remember, expressions are fundamental because they allow us to model real-world situations and solve problems by manipulating these combinations of numbers and variables. Letters, symbols, and operation symbols are essential tools in mathematics because they help us create words and phrases that express ideas clearly. On this slide, we're focusing on algebraic expressions, which are combinations of these symbols that represent numbers and relationships. Think of algebraic expressions as a kind of language that allows us to communicate complex ideas in a compact form. The key point here is that these expressions are the building blocks for solving problems and understanding patterns in math. By mastering how to interpret and manipulate these expressions, we connect to the larger theme of problem-solving and mathematical reasoning. So remember, algebraic expressions are more than just symbols. They're a powerful way to convey mathematical ideas. Now, let's talk about letters or variables that we use to represent unknown numbers. Variables are symbols that stand in for any number from a specific set of possible values, which we call the replacement set. The replacement set contains all the potential values that the variable can take. For example, if I choose a variable like x, it could represent 3 or 7 or any number within that set. This allows us to work with unknowns in a flexible way. And speaking of numbers, let's not forget about numerals, which are the actual digits we use, like 0, 1, 2, 3, 4, 5, and so on. These form the foundation of our number system. Now, when we talk about the language of algebra, it's really built around these key concepts, variables and numerals. Together, they give us a powerful way to express relationships and solve problems. This language is essential because it helps us communicate ideas clearly and work with unknown quantities in a systematic, logical way. Now, let's talk about how we can use letters, numbers, and mathematical symbols to simplify complex statements. Instead of long words, we can translate those into short mathematical expressions, making problems easier to work with. Next, we have the concept of a constant. A constant is a special kind of symbol that always represents exactly one specific number. For example, any numeral like 7, 4, or 11 is a constant because they each stand for one fixed value. Finally, when we look at the language of algebra, it's composed of these key elements: letters, numbers, symbols, and constants that work together to form the foundation of mathematical communication. Understanding these basics helps us to see the bigger picture of how algebra allows us to express and solve real-world problems efficiently. Now, let's move on to see operational symbols. There are many different ways to express addition, subtraction, multiplication, or division of algebraic expressions. Understanding these symbols is essential because they form the foundation of how we communicate algebraic ideas clearly and efficiently. Next, we'll talk about the language of algebra and what it's composed of. This language includes various symbols and conventions that help us write and interpret algebraic expressions accurately. By mastering these symbols, you'll be able to read and write algebra with confidence, which is crucial as we progress in algebraic concepts. So, keep in mind that these operational symbols are the building blocks of algebra, connecting all the different parts of an expression or equation seamlessly. Let's take a closer look at some examples of operational symbols in algebra. These symbols are essential because they allow us to translate verbal phrases into algebraic expressions. For instance, when I say the sum of m and 8, you can see that it corresponds to m plus 8. The key word here is sum, which indicates addition. Similarly, 10 added to c translates to c plus 10, where added to also signals addition. Now, when I mention 7 plus a, it's straightforward. 7 plus a with plus indicating addition once again. Moving on, 10 subtracted from c becomes c10. The phrase subtracted from tells us to perform subtraction, and the order matters, it's c minus 10. Next, the difference of 8 and m is written as 8m. The word difference signals subtraction, and here the order is important. It's 8 minus m lastly. 9 take away d is expressed as 9d, where take away also indicates subtraction. These examples highlight how specific words in everyday language directly translate into algebraic symbols. Recognizing these keywords helps us accurately form algebraic expressions from verbal descriptions, which is a fundamental skill as we continue exploring algebra. Now, let's take a look at some examples of operational symbols. These symbols are essential because they help us communicate complex processes clearly and efficiently within operational diagrams. They serve as universal language, making it easier to understand workflows and system interactions at a glance. For instance, you'll see symbols representing activities, decisions, and data flows, all of which are fundamental to mapping out operational procedures. Recognizing these symbols and understanding their meanings is key to interpreting and designing effective operational models. By mastering these symbols, we ensure our communication is precise, consistent, and aligned with the overall theme of system clarity and efficiency. All right, let's dive into some key terminologies to strengthen your understanding of algebra. First up, an algebraic term. Think of it as a building block. It can be a single number, a letter, or even a product of several numbers or letters combined together. These are the fundamental pieces we work with in algebraic expressions. Next, we have an algebraic expression. This is essentially a statement that contains one or more of these terms connected by plus or minus signs. It's like a mini equation that shows how different parts relate to each other, but it might not be equal to anything specific yet. Now let's talk about coefficients. The numerical coefficient is simply the number attached to a term that gives it its magnitude. For example, in 3x, the 3 is the numerical coefficient. And then there's the literal coefficient, which is a letter used to represent a number. Usually, this is a variable like x or y that stands in for an unknown value. These terms are the building blocks of algebra, and understanding them thoroughly helps us understand more complex expressions and equations. Remember, the key is to see how these pieces fit together to form meaningful mathematical statements. Now, let's talk about similar terms. These are algebraic terms that share the same literal factors, meaning they have the same variables with the same exponents. For example, 3x2y and 7x2y are similar because they both contain x squared, and why recognizing similar terms is important because they can be combined through addition or subtraction, which simplifies our expressions. Next, we have constants. A constant is simply a number, letter, or symbol whose value doesn't change. It stays fixed, like the number 5 or the symbol pi. Constants are key in algebra because they help us define specific values or coefficients in an expression. Understanding these terms helps us see the structure of algebraic expressions more clearly. Similar terms can be grouped together, and constants act as fixed points within those expressions. This understanding ties into the overall theme of simplifying and manipulating algebraic expressions effectively. Now, let's talk about replacing the variable by the given number value, also known as substitution. This is a key step in evaluating algebraic expressions because it allows us to find the specific value of an expression when we know the value of the variable. Think of it as plugging in a number into a formula. For example, if we have an expression like 3x plus 5, and we're told that x equals 4, we simply replace x with 4. So it becomes 3 times 4 plus 5, which simplifies to 12 plus 5, giving us 17. This process is fundamental because it connects the abstract symbols of algebra to concrete numbers, making complex expressions easier to evaluate. Remember, the key is to carefully substitute the given number in place of the variable, and then follow the order of operations to simplify the expression. This step helps us move from an algebraic form to a numerical answer, which is often the goal in solving problems. All right, now we come to the final slide, which is all about practice and application. This is where you get to put everything we've discussed into action. On this slide, you'll see it's titled Vocabulary and points to page 91. The key activity here is the pair activity. What I want you to focus on is using the vocabulary we've learned in real conversation. This kind of practice helps solidify your understanding and makes it easier to recall when you need it. Remember, the goal is not just to memorize words, but to actively use them in context. Pair activities are especially effective because they allow you to practice speaking, listening, and responding naturally. So, I encourage you to collaborate, ask questions, and really engage with your partner. Think about how this fits into the overall theme of effective communication. Practice is essential for mastery. The more you use these words in meaningful ways, the more confident you'll become in your language skills. So I challenge you to take this opportunity seriously, practice actively, and apply what you've learned today. That's how progress happens.